Hi, robotics students. This is Ms. Simonson here to talk to you about using a decision matrix to decide which missions you should concentrate on accomplishing first. So, oftentimes, judges will ask you at a tournament, pretty much every time, they'll ask you, well, why did you decide to do that mission and not this other mission? And you need to have a reason for them. And the decision matrix can give you a good objective way of making this decision and being able to explain it to the judges. It might seem a little bit complicated at first, but I will explain to you how to do it and we'll work together during one of our sessions for you to decide as a team how to rank these different missions. So I'm just doing a sample, and you certainly don't need to do it exactly the way I did it. There are decisions to be made within your team. So, first of all, let me talk about how the decision matrix is set up. Across the top, we have a list of all of our different missions that we have available to choose from. Now, ideally, you'd like to be able to do every single mission and earn every single point. But realistically, you only have 2.5 minutes in which to run the robot missions. And there's no way you're going to be able to do probably even half of these missions. Maybe a veteran team could do most of them. So we have to decide how to prioritize our time during the season and during our robot run of which things we think are going to earn us the most points, because really it comes down to the points. But a high point mission might be super complicated to do, and therefore is going to be a waste of our time to try to accomplish it. So we need to weigh more than just the points. So there are some characteristics down the left side that are some common things that teams like to look at as far as deciding which missions to focus on. One of them is the distance from base. The closer a mission is to the base, two things. One, it takes less time to do it. And since you only have 2.5 minutes, closer is better. Also, distance from base is going to mean that the robot is going to be more reliable to get out and do the mission and come back. The farther the robot travels on a given mission run, the more likely the robot is to have some sort of problem that keeps it from accomplishing the mission. So, what I did here is I, first of all, uh, measured all of the missions and then ranked them from the closest or mission to base being the highest number, and the mission farthest from base being the lowest number. So, number one in this situation. So, looking at the map, the weight machine is in the farthest corner from your launch area. So, I gave it a 1. But the precision points, you don't actually have to leave the launch area to earn the precision points. They are just available to you as long as you don't make any mistakes. Same thing for the equipment inspection bonus. You don't ever have to leave the launch area to actually earn those points. So I gave both of those a 16, which meant I skipped over the 15th ranking. The innovation project model is really close to the launch area. You only need to push it a little ways. And therefore, I gave it the next best rating, which would be a 14, and so on and so forth. Now, this 4 over here has nothing to do with the actual distance from break and or from launch, and I will talk to you about that in a little bit. So then down here, I have points expected. More points, of course, is better. So I started to write in the number of points available on each mission. However, you don't want to just put in the maximum number of points available, because maximum number of points might not be realistic for your team. For example, on the basketball mission, you have a couple choices. You can drop a cube in the crate, which earns you 15 points. If you move the crate up to rest on the middle height of the basketball stand, you get another 15 points. But if the crate rests on the top height's white stopper, you would get 25 points instead of that 15 for the halfway. So I didn't feel that for my particular team in this particular situation, that the top height was very realistic. So I chose the 15 points for putting a cube in and 15 points for making it halfway up the basketball uh, stand. Same thing with the pull-up bar. The pull-up bar, there's two ways you can earn points. You can just pass underneath the pull-up bar and you can earn 15 points. You can also come back at the end before the 2.5 minutes are up and you can pull the robot all the way off of the mat. The robot can raise itself up and hang off the pull-up bar, and that would earn you another 30 points. But if I'm a rookie team, that's not a very realistic thing to have happen. I'd rather put my energy into the robot dance, which also earns points at the end of the mission and can earn me 20 points. That's going to be a lot easier to accomplish than these additional 30 points with the pull-up bar. So I'm just going to put 15 points down for the pull-up bar because I think it's pretty straightforward to run underneath the bar. That would be a pretty simple thing to do. So you would finish putting in all the points. Now, you could also look at the number of turns that it would take, which missions are going to require a lot of turning, which takes more time. So the fewer turns, the better. If you can go straight out and straight back, that's going to give you a high ranking. If you have to turn multiple times and go around multiple objects to get to that spot, you're going to give it a ranking of like 1 or 2 or 3. Also, kind of estimated time is another thing you could figure out. Also, the complexity of what attachment is going to be required for the robot and how is that attachment going to need to move. If the robot is simply going to push on something, that would get a pretty high ranking because it's not going to be very hard to accomplish that. And it's not going to take extra time to run a motor or something. But if the robot is going to need an attachment that maybe has a grabber or a forklift on it in order to accomplish that movement, or it's going to be a very specialized attachment that you have to take on or off the robot, that's going to waste a lot of time. And therefore, I'd give it a very low ranking in terms of that particular mission. The other thing you might want to look at as a team is the ability to combine it with other missions. Is it nearby other things that would use a similar action of the robot? So are there 2 missions that would require lifting or 2 missions that would require pushing that are really close to each other? And so you could give it a score based on the ability to combine with another mission. So once you've done all of these numbers, you're going to go to this red column of importance. And this is where you're going to use a scale of 1 to 5 to say, is this a not very important characteristic or is this a really important characteristic? A not important characteristic is going to be a 1. So I'm going to say that because I'm a rookie team, the ability to combine with other missions is not as important. So I'm going to give it a ranking of 1. The complexity of the robot attachment, that might be like maybe a 3, because if I'm a rookie team, I don't want to have to be building super complicated things. That could be a challenge for me. So that might be a 3. Once you've done these, you can have repeats in here, but you do want to try to have a good range, because otherwise, if all of these are a 5, then there was really no point in doing it. So once you've done all those, you'll notice what's happening down here. There's a number of points being populated. If we click on one of these cells, you can look up here and see that there's a formula that's been entered. And what it's doing is it's taking this 16 times 4 and then adding it to the 25 times 5, and then adding it to this number times this number and this number times this number. And if you had other numbers in here, it would do all those. So I haven't put in all the numbers yet, but you can start to see that you start to get a score down here. A high score is a mission that is more important for you to do. Now notice that we have only finished for some missions, so these scores aren't complete. But let's go down to precision points. Wow, look at that. Even without all this other data, precision points is worth a total of 364 decision points, I'll call them. So we would definitely want to aim for precision and not making mistakes with our robot and not having to pick our robot up while it's out in the middle of the table. So that's going to be more important than anything, making sure we have good, reliable missions. After that, I'd look and say, oh, well, look at this. Basketball might be a good choice, or the bench might be a good choice because those are going to give me some good things. Now, you don't want to use this information because there's not enough stuff in here for you to make a decision yet. But because we don't have other things like the estimated time or the complexity, that's going to definitely change the values here. Our equipment inspection bonus is also an important thing to do because it has a fairly high number of points. All right, so hopefully this helps you move forward with doing your own decision matrix for your team. Bye.